Hello students, welcome to Automotive Component Design. We are in module 5. Already we have seen about design of cylinder and cylinder head. Now we are going to see about design of piston. Okay, particularly in design of piston, they will ask you to find out this thickness. Piston head is there, no? We have to find out piston head thickness. Then we have to find out whether it need ribs or not. Whether it need ribs or not. Suppose if it is having a crown like this means, okay, kind of deflection, okay, because that is called as cup, okay. This is called cup. Normally flat plate type also available, cup type also available, okay. So if there is a cup means whether the particular piston need cup or not. Suppose if it need cup means what is the radius? This radius is there, no? This radius. What is the radius? That we have to find out. So three things we are going to find out. First of all, the thickness of the piston head. This one we are going to find out. Then whether this particular piston need rib or not. This element is there, no? This support. Whether it need rib or not. Suppose if need ribs means how many ribs it need. Then whether it need a cup type head or normal flat plate type head. Suppose if it need cup type head means what is the radius of the cup. Okay, these three things we need. First we will focus on piston head thickness. Okay, piston head this thickness. First we will focus on that. In two ways we can find out this thickness. One is through strength consideration. Okay, through strength consideration we can find out the thickness. Okay, strength consideration. So in strength consideration this is the formula D into root of 3 by 16 into P max divided by sigma B, where sigma B is called as permissible bending stress. Sigma B means nothing but permissible bending stress. P max is maximum gas pressure. Okay, when the fuel burn inside, it will create a pressure, no, inside the chamber. So inside the burning chamber it will create a pressure, that gas pressure, that is called P max. What is the maximum gas pressure? Then capital D means cylinder bore diameter. Okay, so this bending stress mostly it will be equal to sigma T. Okay, this bending stress mostly it will be equal to sigma T, because mostly the piston head, particularly this piston will be made up of a brittle material only. So in case of brittle material, bending stress will be equal to tensile stress. Okay, so to find out tensile stress, they will have ultimate strength. So ultimate strength divided by factor of safety, that will be equal to tensile stress. Okay, permissible tensile stress. So this is mechanical consideration or strength consideration. This is the strength consideration formula. Using this we can find out the thickness. One more consideration is there, that is heat dissipation. Okay, using that also we can find out thickness of the head. Oh, how we can find out the heat dissipation? So particularly in the combustion chamber, fuel is burnt, so it will generate a lot of heat energy. So we have to consider that also. So for that formula is TH equal to capital H divided by 12.56 into K TC minus TE, where TC minus TE means temperature. TC means temperature at the bottom of the piston. Okay, here TE means in the edge, in the bottom. Sorry, TC means in the top. Okay, temperature on the crown, TC. TE means temperature at the bottom. Okay, mostly they will give TC minus TE value in the question. Okay, then H means amount of heat conducted. Okay, amount of heat conducted on the piston head or through the piston head. How much amount of heat is conducted through the piston head? Okay, that is called capital H. Okay, then K is thermal conductivity factor. These things you might have studied in HMT, heat and mass transfer. These formula you might have studied in HMT. Okay, relation between heat conducted and the thickness. So this is the formula.